Hello guys, welcome to another requested video. This one is question number 8 from paper November 2017, paper 2-2. So this one, it looks pretty scary. As you can see, we have circles, we have triangles, we have many things going on. So in those cases, as always, don't rush, go slowly, step by step, okay? So first thing, read your question. The diagram shows two circles, center O. So as you can see, we have one center O here. We have this circle and the big circle. Okay, so we have two circles. Now A, B, C, D are points on the large circle. So A, B, C, D. Okay. Now E, F, G are points on the small circle. E, F, G. Now, so we have C, G, D and C, F, B are tangents to the small circle. So this line and this line are tangents. So whenever you have something like that, you have to know that if the tangent meets the circle at this point and this point meets the center, we have to know that this angle here has to be 90. So that's the first thing we can derive from that information. Okay. Now next thing is the lines A, E, O, C and F, G intersect at 90 degrees at X. So this line and this line meets at 90 degrees at X. Okay. Now also we have been given the angle GOX is Y. This is Y. So now let's move on to question part 1. So we have to find each of these angles as simply as possible in terms of Y. Okay? And give your reasons why. So first we have to find GEO. So first, where is GEO? GEO. So this is F, sorry. GEO will be this one. So by observation, if you see, we have this small circle. This is your center O, and my angle at center is Y. What is my angle at circumference? So you have to know this theory, which says that angle at center is always 2 times angle at circumference. So by using this theory, you can see that if this is Y, this is center, the angle at circumference will be half the value of this. So it will be Y divided by 2. So that is one way of doing this. So Y divided by 2, because angle you have to write at center is 2 times or twice angle at circumference. Now let's say if you did not know this theorem, what would you do? So you would just observe. For example, you would see that we have OG and OE. They are both radius of a circle. So meaning that these two has to be the same. Now let's take this shape out. For example, I have this triangle right now. So I'll just take this triangle out. So we have O here. And we pretend they are the same. So these two are the same, right? So radius, radius. This is E, this is G, and this is O. So if these two are the same, these two angles will be the same, right? And if this is a straight line, AEOC is a straight line, this is Y, this has to be Y, so 180 minus Y. So this angle here will be 180 minus Y. Now as you can see, this one is a triangle. So to find the angle GEO, we can first find the angle of these two. So we take 180 minus this angle, you will have Y. So since these two are the same, you will just do Y divided by 2 to find one of those. So this is another way to find this angle without using the theory. So it will be the same value. Now for part 2, we have to find the angle GCX. So where is GCX? GCX. So we have to find this angle. So one thing we can do here is we can take out the triangle. Let's say we have the triangle OGC. If you observe O, G, and C, right? Let's label this. Now you will see that this is given to you by Y, and this is 90. So what is this one? This is just will be the third angle of a triangle. That will be 90 minus Y. Okay. So we can explain that. So this will be 90 minus y, because if you observe, we have O, G, C is a right angle triangle, and C is the third angle, is a third angle that we need to find. So third angle, basically it is 180 minus the rest, which is 90 minus y, which will give you this value. That is for part 2. Now we have to find the angle DAB. So where's DAB? Let's have a look. DAB. So we have to find this angle. Okay, so from the information that we were given in the first part right here, we have CGD and CFB are tangents to the circle. So basically, these two are tangents, so these two has to be the same. Right. Now, one thing we can see is that if this is found to be 90 minus y, so this also has to be 90 minus y. So angle C will be this plus this. That should give you 180 minus 2y. That is your angle C. Now in this case, if you observe, we will have a shape here inside of the triangle, of the large triangle. We have A, D, B, and C. Okay, so this is a quadrilateral which touches the circle. In that case, we can use a theorem which says that the angle that are opposite each other, they have to add up to 180. They are called the supplementary angle. So basically, from this we can derive that angle A plus angle C are supposed to give you 180. So angle A will be equal to 180 minus angle C. And let's just do that. That will give you 2y. So write down angle A DAB will be equal to 2y. Because you can write down the angle A and angle C are supplementary angles. That's one of the options that you can choose to explain your answers. Supplementary means they add up to 180. Okay, that is one way. And the other way, if you want to do this, is if you look at this shape, if you just rotate that this way, we have this big triangle ADC, and this is your diameter. So you have to know that when you have a triangle above your diameter and this point touches a circle, this has to be 90. So same way, if you look at this one as well, this one also touches this circle, so this has to be 90 as well. Now this is 90 minus y, 90, and this has to be a third angle, which is 180 minus this 2, that will be y. So let's mark this down. So this angle here, that will be y. So since they are the same, that will be y as well. So this 2 will be 2y. So that's another way of doing that question. Now let's move on to part B of this paper. So we have to complete the sentence. Triangle EGC is congruent to triangle, which one? So congruent means same, exactly the same to triangle. Let's observe. So we have triangle EGC. So E is here, G is here, C is here. So by observation, it will be exactly the same to triangle EFC. That makes sense, right? So let's write this down, EFC. Now for part C, prove that triangle ADC is similar to triangle OGC. So one way of proving two triangles are similar, you can prove that all the angles, all the corresponding angles are equal. That is one way of proving the two triangles are similar. So let's observe which one are we referring to. So we have triangle ADC, so ADC and OGC. So we have these two big triangles. So what can we do here is let's draw these two triangles. So we have A, D, this is A, D and C, and we have the small one, which is O, G and C. Okay, so from the information from the first part, we have seen that this is 90, and this is also 90, and this is the same value, which is 90 minus y, and this is also given by the same value, which is y. If you observe, for the big triangle ADC, this is 90, this is y, and this is 90 minus y. And for the small triangle, we have OGC, 90, 90 minus y, and y. So we can just write the reason. So first one, we have angle ADC is equal to angle OGC, 90. Right. Now part 2, we have angle ACD, that's right, ACD is equal to OCG, that was 90 minus y. And last one, DAC is equal to angle GOC, which was y. Okay, so by proving the corresponding angle are the same, we have shown that the triangles ADC and OGC are similar. So in that case, you have to write your reason, as you can see. So the reason why this is 90 is because they are the angle. This one is, you can write tangent to circle, and this one is angle on a semicircle. That's the reason. And this is shown as in part part 2 shows that. So question part A, part 2 shows this is the angle, and the reason why they are the same is because C is common angle in both triangle. As you can see, they both have the same angle C, that's why they are the same. And finally, this one is just the third angle of a triangle, that's why it is the same. Now let's move on to part D. What special type of quadrilateral is AOGD? Let's have a look. What is that? So we have AOGD. So the one thing we can do is let's draw this first and see what can we derive. So we have this AD, this and this, something like this, right? Something like this. That will be A, that will be D, that will be O, and that will be G. So from the diagram, you will see that if you extend this line, this angle is 90 and this angle is 90. So what does it mean? It means that these two lines will be in the same direction. So by proving that these two are parallel to each other, we have proven that this is a trapezium. Okay, that is part D. Now for part E, find the ratio, first one, of area of triangle OGC and area of triangle ADC. So where's OGC? OGC and ADC. So here we have two big triangles to compare with. So we have to look at the sides to be able to find the ratios. So let's see what do we have here. So let's take those triangles out. So let me draw this one first. I will draw the triangle A, D, and C. That's the big one. Okay, that's A, D, C. This is 90. And from observation, you can see that this side AC, what is the value of AC? Because this is your big circle, okay? So let's observe, this is your big circle. We know that O is your center, so OA is the radius of the big circle, and OC is also the radius of the big circle. So AC will be equal to 2R. Okay, I hope that is pretty simple for now, because we have the big circle, center O, OA is your radius, but OC is also your radius, so the length of AC will be 2 radius. Now let's look at the small triangle. So for this one we have Let's draw this here. We have something like this. So here we have O, G, C, and the angle is 90, as you can see. So as you can see, what is the length of OC? OC is just R. Okay, so in that case, we can compare their corresponding sides. As you can see, we compare these two sides with each other from the triangles. So from the information that we just seen, the sides has a ratio of 1R to 2R. But now, since we're comparing area, we have to square both sides. You'll have 1R squared to 4R squared. Now we have to simplify. R squared goes away. So the ratio is 1 to 4. Now finally, find the ratio of the area of triangle OGC and the quadrilateral ABCD. Now where is ABCD? Let's have a look. ABCD is this big shape, which is also equal to, so how would you find the area of ABCD? You would say, okay, I can just find the area of this triangle first, and then times 2 because they are the same, so to find this ABCD. So same thing, same way of thinking. You go here is, you write down, the ratio was 1 R squared, right? 1R squared to 4R squared for this one. So to find the area of this, we have to multiply this by 2, right? I hope that makes sense, right? Because this one is the area of triangle ADC, and for ABCD will be the big one. We have to multiply this by 2 to find the area of the big one. Now we just have to simplify. You will have on one side is 1 R squared, 8 R squared. So simplify. That will be 1 to 8. So that will be your question number 8. So I hope that was somewhat useful. And as always, you can see that when something is really hard, it seems to be very complicated, always read the information and go through the questions step by step. And you can derive many things to help you to solve your question. So as always, if you guys have other questions, leave a comment below. I'll get back to you guys. And thank you for watching. I will see you soon.